Welcome to the channel. In this video we are going to discuss system of circles important problems. Here the question is given, show that the circles x square plus y square plus 2ax plus c is equal to 0 and x square plus y square plus 2by plus c is equal to 0. These two circles touch each other if 1 by a square plus 1 by b square is equal to 1 by c. That means if the given two circles are touch each other, we have to prove that the condition 1 by a square plus 1 by b square is equal to 1 by c. So that's why given circles let s is equal to x square plus y square plus 2ax plus c is equal to 0. Here finding the C1 is equal to center of the circle, C1 is equal to here coefficient of x is 2a, so that's why here half of the coefficient of x with a negative sign, so coefficient of y is 0, so that's why C1 is equal to minus a comma 0, and here radius r1 is equal to here root over, r1 is equal to root over, so here g square, that is a square, and f is here 0, so that's why 0 square, and c is here minus c. Minus c value is c only. We get r1 is equal to here root over a square minus c. So we have center c1 and here r1 is equal to root over a square minus c. Similarly, the second circle is taking as let s dash is equal to x square plus y square plus 2by plus c is equal to 0. Here finding the center. So we know how to find the center. C2 is equal to here. So there is no x coefficient. So that's why that is 0. So that means g is 0. So coefficient of y 2b. So half of the coefficient of y with opposite sign, that is minus b. This is center. C2 is equal to 0 minus b, and here r2 is equal to, we can find root over, so this is g dash square plus f dash square minus c dash, so here, so g is 0 square and f is here, so b square, so that's why b whole square, and c is c only here also, so that's why minus c, so we get r2 is equal to root over b square minus c. r2 is equal to b square minus c and r1 is equal to root over a square minus c. Now what they are telling that? So clearly if the circles touch each other, that means suppose if you take the circle s is equal to 0 is like this and the circle s dash is equal to 0 is like this. So these two circles are touch each other either externally or internally. So now I consider here the circles touch each other externally. So this is center C1 and this is center C2 and here this is R1 here and this is radius of the second circle, that is R2. So that's why here, so when the two circles touch each other externally, suppose considering here, suppose when the two circles touch each other externally, suppose C1, C2 is equal to the condition we know that R1 plus R2. C1, C2 is equal to R1 plus R2. Now here we have C1 is minus a comma 0 and C2 is 0 comma minus b. Now finding the distance between the two centers, suppose if you take this is x1, y1 and here this is x2, y2. So we can write the distance between the 2 points is root over, so x1 minus x2 whole square, that is minus a minus 0 whole square and plus, so 0 minus half minus b whole square, this is y1 minus y2 whole square, which is equal to, here r1 is we have root over a square minus c and r2 is we have here root over b square minus c. So now here which is equal, which is implies we get root over this is a square and here this is plus b square which is equal to, so root over a square minus c and plus here root over b square minus c. See what I am doing is here squaring on both sides. So when you square on both sides here, so this implies root over a square plus b square whole square which is equal to here root over a square minus c and plus root over b square minus c whole square. See now here in the left hand side square root gets cancelled and we get here, so root over a square plus b square whole square, square and root gets cancelled. We get here a square plus b square which is equal to the right hand side which is like a plus b whole square. That means a square, that is root over a square minus c whole square and plus 2ab this is it. So that means 2 into root over here root a square minus c and root b square minus c, writing within the one root, that is a square minus c into b square minus c, a square minus c into b square minus c root over and b square. So that means b is here we have root over b square minus c whole square. So now here if you simplify, we get here further which implies a square plus b square which is equal to, here square and root gets cancelled, we get a square minus c and plus here, so 2 into root over a square minus c into b square minus c, a square minus c into b square minus c, and here also square and root gets cancelled, so we get here b square minus c. So if you observe here, the right hand side and left hand side a square and b square are gets cancelled. So we have here in the left hand side 0 is equal to, so we have minus c and minus c, this is minus 2c and plus 2 into root over, so a square minus c into b square minus c, a square minus c into b square minus c. Now further we can write, if you bring that minus 2c left hand side, it becomes a plus 2c is equal to 2 into root over a square minus c into b square minus c. So now here 2 gets cancelled, again squaring on both sides, so then we get here, this implies c whole square is equal to root over, this is a square minus c into b square minus c, so whole square, then here square and root gets cancelled, so we have here c square is equal to a square minus c into b square minus c. So then if you multiply the right hand side, so with a square, so this is a square into b square minus c, and here with minus c if you multiply, so minus c into b square minus c, so which is implies here c square is equal to, we get here a square b square and here minus a square c and here minus b square c and here minus into minus is plus c square. See, observe here again left hand side and right hand side c square is also gets cancelled. Now what is here, we have again 0 is equal to a square b square, and in these two if you take minus c common, then we get a square plus b square. See here, so now which implies this minus c into a square plus b square, if you write left hand side, it becomes plus c into a square plus b square, so which is equal to a square b square. Then if you bring this a square b square to the left side, then it can be written as a square plus b square by a square b square, which is equal to, if you send this c to the right side, it becomes 1 by c. Now further which can be written as, this is a square by a square b square and plus b square by a square b square, which is equal to 1 by c. Now b square gets cancelled, a square gets cancelled. Finally we get here. So this is 1 by a square plus 1 by b square is equal to 1 by c. So which is only the required condition, we have to prove that. So if the two circles touch each other, so then 1 by a square plus 1 by b square is equal to 1 by c. So this is the required thing.